Hello, my name is Micaela Denise M. Litawa, a BSN student. Today, I will present about the buffer and buffering capacity, and I will do an experiment, so let's get started. Welcome to the world of buffers where chemistry meets balance and its stability. In this lab, we're diving into the fascinating world of how our bodies and even industries keep their pH levels in check no matter what gets added to the mix. First we will do is explain what buffer and buffer capacity are. So, what exactly is a buffer? A buffer is a solution that resists changes in pH when small amounts of an acid or base are added. It is typically composed of a weak acid and its conjugate base, or a weak base and its conjugate acid. Buffers help maintain a stable pH, which is crucial in many chemical and biological processes. The importance of pH stability in biochemistry is crucial for maintaining enzyme function, protein structure, cellular metabolism, and overall biochemical equilibrium, even life equilibrium. Deviation from optimal pH ranges can lead to serious dysfunctions in biological system, highlighting the delicate balance required for life processes to occur properly. The concept of a weak acid and its conjugate. Weak acids and weak bases are substances that do not completely ionize in solution, and they establish an equilibrium with their conjugate bases or acids. These pairs are crucial in maintaining pH stability as they can neutralize added acids or bases. What is a buffer made? A buffer is made of a weak acid and its conjugate base, or a weak base and its conjugate acid. These components work together to maintain a stable pH in a solution by resisting changes when small amounts of acid or base are added. How do buffers maintain pH stability? Buffers maintain pH stability by neutralizing small amounts of added acids, hydrogen or base, hydroxide ions, which prevents large shifts in the pH of a solution. This is possible because buffers consist of a weak acid and its conjugate base, or a weak base and its conjugate acid, which are in equilibrium with each other. Factors affecting buffer capacity. The concentration of the conjugate acid and conjugate base play a crucial role in determining the buffer capacity of a buffer solution. Buffer capacity is a function of how effectively a buffer can resist changes in pH when small amounts of acid or base are added. And this effectiveness depends on the relative concentrations of the weak acid and its conjugate base, or the weak base and its conjugate acid. Factors influence buffer capacity. Buffer capacity is influenced by the concentrations of the buffer components, the pH relative to the pKa. pKa, the temperature, and the volume of the solutions. The stronger and more concentrated the buffer components, the higher the buffer capacity will be. I have already discussed the basic of buffer and the parts of a buffer, how they work, their importance, and factors that influence buffer capacity in an easy-to-understand manner. How buffer work equilibrium between the conjugate acids and base. Conjugate acid-base equilibrium represents a dynamic balance between an acid and its conjugate base, or a base and its conjugate acids. This equilibrium allows buffer to maintain pH stability by adjusting the concentration of the acid and base in response to the addition of acids or bases, preventing large fluctuations in pH. Buffer capacity and how is it measured? Buffer capacity is the ability of a buffer solution to resist changes in pH upon the addition of acids or bases. It is determined by the concentrations of the Popper component and the pH range. The Popper capacity can be calculated by measuring how much acid or base is required to cause a 1 unit change in pH. With the formula related moles of acid base added to the change in pH and solution volume. The first thing we'll do is put on personal protective equipment, which is essential in the laboratory to ensure the safety of individuals working with potential hazards. In this experiment, we'll explore the science behind vapors, their components, and how they maintain that delicate balance. Prepare the test tube and name them 1 to 8 once you have all the necessary lab supplies. First, use a pipette and add distilled water with 5 ml and put in test tube 1 and 2. Then the 2% egg albumin for test tube 3 and 4. And next is phosphate vapor for test tube 5 and 6. And lastly, 0.1 mkcl is for test tube 7 and 8. After that, find the pH meter of each substance. When the pH meter reading stop varying, it says done. Use a tissue or cloth to dry it after use. And better yet, wash it before using another chemical. According to the pH meter, the pH of distilled water is 4.21, that of egg albumin is 8.26, that of phosphate vapor is 6.54, and that of potassium chloride is 7.33. Next, we will add either an acid or base to each test tube to see how they affect the pH. A drop of 0.1 meter hydrochloric acid should then be added to test tubes with odd numbers. For test tubes with even number, add 3 drops of 0.1 meter sodium hydroxide. Based on pH changes, interpret results in test tube 1 is acidic while test tube 2 is basic. Test tube 3 is neutral while test tube 4 is acidic. Both test tube 5 and 6 is acidic. Test tube 7 is neutral while test tube 8 is acidic.